Hello dear friends, now let's start with this example. Calculate change in volume with respect to temperature at constant pressure for 1 mole of an ideal gas. Okay, let's solve this problem. Now, ideal gas. We know that ideal gas equation is PV equals to nRT, right? But we have provided that there is 1 mole, so n equals to 1, PV is equals to RT. We have to calculate change in volume with respect to temperature. Okay, we have to take derivative of volume with respect to temperature at constant pressure. Now pressure is constant, one term is constant, then it will be partial derivative. D changes to dBA at constant pressure. We have to calculate this. Now let's see. V is equal to, let's rearrange this, RT upon P. Therefore dBV by dBT at constant pressure equals to dBA by dBT of RT upon P. Now let's take constant outside. Pressure is constant and R is the gas constant. R by P and dBT by dBT equals to 1. Derivative of T will be 1. So we got the value at constant pressure equals to R by P. So simple. Got it? Now we will move towards Euler's reciprocal rule. Okay. Now, what is the Euler's reciprocal rule? If Z is a function of x and y, what it implies? That is, with change in x or with changing y, value of z will also change. Okay. Now then it will say dz is a perfect integral, exact integral exact differential only when dBz by dBx at constant y, change in z with respect to x at constant y, and here this whole term, the differential of this whole term, dB by with respect to y. Now y was first constant, now let's differentiate with y, dB y, and whole thing at constant x will equal to, now first we have taken dBz by dBx, now we will take with respect to y, differential with respect to y, dBz by dBy at constant x and dB by dBx at constant y. If this condition is followed, then only dz is the exact differential. Now how we write exact differential? Exact differential is written as dz is equals to dBz by dBx at constant y dx plus dBz by dBy at constant x dy. This is the exact differential of z. Okay, and this is written as in the form of this. If the if this condition is followed only. If this condition is followed, then only we can write it in the form of exact differential. This is what the Euler's reciprocal rule states, and we can write this in the form. We can write it in the form of, if we say it is m and it is n, then dz is equals to m dx plus n dy. This is short form, where m is equals to dz upon dx at constant y, and n is equals to double z by double y at constant x. That's it. Do you got it? This is the Euler's reciprocal rule, and it is important. Now let's see the cyclic rule. Another rule is cyclic rule. This is cycle. If this is x, here is y and here is z, then if x is function of y and z, then we can write dabba x by dabba y at constant z into dabba y by dabba z at constant x into, see, dabba x by dabba y at constant z into, now it is gone, now dabba y by dabba z at constant x, and this time dabba z by dabba x at constant y is equals to -1. This is the cyclic rule. Okay, this is when the x is a function of y and z, then derivative x with respect to y at constant z, x with respect to y at constant z, then y with respect to z at constant x, and then z with respect to x at constant y. That's it. Now let's have another example. T is function of temperature and pressure. Show that dV is an exact for an ideal gas. Now, how can we show that the exact differential? If we have to show exact differential, what we see? We will see Euler's reciprocal rule, right? If this follows the Euler's reciprocal rule, then only we can say that it is exact differential. So let's see that. According to Euler's reciprocal rule, what should be the equation? See, dabba V by dabba T at constant pressure and dabba by dabba P at constant temperature should equal to dabba V by dabba P at constant temperature into dabba by dabba T at constant pressure. This is Euler's reciprocal rule, and if it is satisfied, then we can say that it is exact differential. So let's calculate first dabba V by dabba T at constant pressure. Dabba V by dabba T. First, let's write the ideal gas equation. PV equals to RT if it is 1 mole. Then now calculate dabba V is equals to RT by P. Therefore, dabba V by dabba T at constant pressure will be equal to delta V by delta T at constant pressure will be R by P. Now this first we obtained this value. Now let's differentiate it with respect to pressure at constant temperature. So delta by delta P of R by P at constant temperature. R is gas constant, it is constant. Now delta P by delta P 1, therefore it is equals to R. You can say that it is R. This is one equation, this is equation 1. Now let's integrate delta V, let's calculate delta V by delta P at constant temperature. Delta V by delta P at constant temperature will be equal to V is equal to RT by P. Now constant is R and temperature also constant, RT, it is equals to RT into R and T are constant, RT into derivative of 1 upon P with respect to pressure. So it will be minus 1 upon P square. Derivative of 1 upon x is minus 1 upon x square. So is minus RT upon P square. Now let's calculate. This is, we got this value now. Now delta by delta T of RT upon P square at constant pressure, it will be, let's calculate here, it will be, see, pressure is constant, RT also constant, R also constant, so R by P square into delta T by delta T is equal to 1, so it will be R by P square. Let's check this, there is something wrong here. Delta V by delta T at constant pressure and delta by delta P at constant temperature. Now delta V by delta T at constant pressure is equals to R by P, and delta by delta P of R by P, R into derivative of R is constant and delta by delta P of 1 upon P will equal to minus R by P square. And here also it will be, this is minus or minus and therefore sign is minus. Okay, this is equation 1 and this is 2. So this equality is followed. Therefore as 1 equals to 2, therefore V is equals to function of Tp. Here dphi is an exact differential. Okay, so let's stop here today, and if you have any doubts you can tell me on the comment section. Okay, thank you so much for watching.